The key issue with thunderstorms in this region is that they give the absolute highest gust wind speeds. Now, for the very, very tall buildings, that's not too critical because they occur down low. For Aldar HQ, they were really critical.
Thunderstorm winds are strongest between 50 and 150 meters above ground. Aldar HQ is right in the danger zone.
In advance of getting the wind tunnel tests, we'd speak a lot with the wind tunnel engineer, Roy Danoon, and Roy would wind me up about the kind of loads he was getting, etc. And knowing that the piles were going in as we spoke.
Wind hitting Aldar HQ's sail-shaped facade puts the building's narrow base under pressure. The wind wants to twist the structure. The foundations must be strong enough to resist these forces.
A little bit more smoke there, Doug. And if you could just crank the speed up in the tunnel just a touch. A little bit more.
Danoon analyzes the wind tunnel data. Fortunately for Gibbons, it's Danoon's jokes that have no foundation.
And I got the results back from the wind tunnel test, and they were within an absolute whisker of my early predictions. And I was just delighted by that. I couldn't wait to get on the phone. They were pretty relieved, I think, because I think they'd been sweating on it a bit.
It was a great relief to know that Roy was just winding me up, and that in actual fact the wind loads were very much in line with what our expectations were.
The results of the wind tunnel test are great news, but the relief is short-lived. Now the structure needs a super strong backbone or core. But again, conventional building won't fly with this design.
For Aldar HQ, one core wasn't enough. We needed two cores, in fact, to take all the loads down into the structure.
Aldar HQ needs two concrete cores for extra stability. The twin spines rise a full 125 meters from the concrete slab to level 23. Reinforced with 6,500 tons of steel, these cores will transfer the loads into the piles. But to channel these forces safely, the concrete must be cast without any flaws. They need a way to build the cores as two single pieces of concrete. The answer? To Slipform. It's a clever way to build big concrete towers. Liquid concrete is poured into a giant mold, which forms the shape of the structure. The mold slowly climbs up the core as it's cast, forming a single concrete tower without any joins. Seamless concrete will ensure the HQ's cores are strong. But these 125-meter backbones must be built in only 6 months. It's the same process ongoing at this Dubai construction site, led by the Aldar HQ team.
We are calculating how much per hour we need to climb, and then how much concrete we need to place in every hour.
Slipform is fast, but on this schedule it's not fast enough. O'Sullivan has a trick up his sleeve to speed up construction.
We set a challenge to both cores, who could get up there first.
More, get up.
The teams battle to reach each level before the other. The cores grow meter by meter under a constant cycle. The concrete is released and poured around the steel reinforcement. Hydraulics anchored to the structure raise the mold or shutter so that the next layer of concrete can be poured.
And manpower is a key focus because slipforms are very labour intensive. You need to make sure that the guys are on deck, they're there at the right time, they're doing the right works.
4 months into core construction, the two teams are neck and neck in the race to the top. Core 1's team leader keeps a close eye on Core 2's height.
It's been my benchmark, so if I'm doing better, I'll be ahead of them. It's a lot of pressures are there. My boss is telling me, do this, go up, go up, go up. But it's good, the pressure is good.
Core 2's leader also feels the strain.
I'm working 24 hours today. I try to finish more earlier than the other core.
Every month, the builders pour enough concrete to fill 1.5 Olympic swimming pools. But the teams aren't home and dry yet.
It was still a challenge to finishing. Cores are renowned for going up quickly and sometimes having problems, so there's a lot of coordination effort that goes in to make sure that they do go up on time. We had structural steel elements to cast in. We had crane connections to get right.
After just 6 months, the 2 cores are approaching the top. Core 2 is only a metre or so behind, but Core 1 push ahead to victory.
Core 1 won the race. It's really good to know.